Okay, great. So if I'm looking too much to this site, because I have my notes over here, don't be bothered with that. Okay. So programming as such is a very powerful tool to make um, a lot of different things. For that, fundamentally, you use something called an IDE or an integrated development environment. For example, let's say a very basic example, the laptop you are using, right? You can browse, browse on the web. You can uh, see movies. You can buy things. You can make Word documents as such. That is an environment. The desktop, like the OS, which is OS, which is running the desktop. OS as an operating system, which is running the desktop, is an environment. Now, for developing programs and logics on your phone, you use something called an development environment. One of the common examples is VS Code. VS Code is a code editor, but then you can download things and attach plugins as such to VS Code to make it even more efficient and make it what is called a development environment. Okay, so moving on. Why programming? Humans are intelligent people. I mean, intelligent creatures as such, as you can see around. But then they can be really dumb sometimes. But then repeated work causes fatigue, right? You can't expect us to do the same thing again and again and expect the correct results. So computers are machines which can be instructed to do the thing again and again without any breaks as such. So how it all started? There was this guy called Alan Turing. I don't know how many of you know him, but then he was this famous mathematician from, famous as in after war he became famous. Famous mathematician from the UK. He was a what is called a cryptographer. So back in the day, German warships, specifically the Navy side of Germany, used what is called a Enigma machine to send encoded messages. This Enigma machine changed its algorithm every 24 hours. So they had literally 24 hours to break whatever code they had. Alan Turing and his team, which is called the Hut 8, which broke these codes, developed the first physical computer which had rotating dials to represent zeros and ones. Now, why I'm telling you this? Because it's actually important to to what was actually there and where we are actually coming from. Now, zeros and ones can be represented as voltages across magnetic bits from a hard disk. So, thinking about that, the clunky circular disk which rotated physically to represent zeros and ones, to coming to this age where you can literally represent zeros and ones as voltages across diode. Like, it's simply mind blowing. Okay, so why programming again? You can do very interesting things in this. You can smoothen your workflow. I'll show you a simple example. Um, how many? I mean, like, how do you actually change your volume in what to say in your computer? I actually expect answers for this.
We
The volume
usually use the
button.
function keys, and then change the volume.
Okay. So I've used a little bit of programming magic to do something. Well, like when I hold my windows and scroll up and down, I can change the volume of the whatever I'm listening to. See things like this. I frequently visit Reddit. So like what I did was I just mapped the two key of my numpad to open Reddit whenever I hit it. Oh, okay. Well, this is just precariously lazy things. But then look at the software which they're using, Teams, which has been obviously developed by an excellent team of programmers back at Microsoft to make it, right? Now, moving on. Computers are dumb, but then they can perform continuous, repetitive tasks at producing accurate results each and every time. That's the important part of computers being dumb. They could be dumb, but then if you say something properly, like if you instruct it properly, they can be like one of the biggest, what to say, weapons at your arsenal, more than any explosive device. Um,
So
Moving on.
Aditya,
Yeah,
you
go on.
told computers don't experience fatigue like humans, but is that like true? Because don't computers also stop working at some point of time? Uh, they uh, like deteriorate. I think the correct statement is the computer's fatigue does not cause an alternate in results. Like in human, it does. Like if
Oh,
I'm
like even in
fatigued, maybe
computers
if
it
I
does.
calculate, I will sometimes write 3 minus 1 is equal to 1. But the computer does not do that anytime. So I guess that is
Yeah,
just
that actually makes
uh,
sense.
yes.
Yeah, that's actually pretty good. Okay, you can stop me anytime to ask doubts. I don't mind that. Okay.
Yeah.
Moving on. Yeah. Binary and machine language. Computers are nothing but electronical machines, so they understand only two states, which is zero, I mean, like, which is off and on. So we represent it as zero and one. Um, for I mean, like, so that's where binary comes from. You can't say, let's say, um, you can't say hi, I'm Aditya in binary to another person and expect them to understand. But then a computer will be able to perfectly understand it because that's the only two states it understands really well, which is zero and one. Next thing, assembly language. Assembly language, because humans had to interact with computers, right? So we had to come up with a way to interact with the computer without actually clicking zeros and ones. Like NASA sent their Apollo mission in 1969 with, I mean, like, if you have seen the memes, it's 14 kilobytes of RAM. So how the RAM were physical bits, as in there was this grid. I mean, like, I'll show it rather. That's better. Um, yeah. So there were these physical bits which were circular and woven around in. Does it show? No, it does not show. Now I have to find it. Okay, so there were these physical circular rings woven across a grid-like mesh, where you would magnetically induce clockwise magnetic field or an anti-clockwise magnetic field to read it as zero or one. Now, this particular memory module, that is the 14 kilobytes of RAM, was used to transmit data from the rocket itself back to Earth stations. So again, why I'm telling you this, just to appreciate the fact that where we were and where we are actually coming from. Okay, moving on. This assembly language. Now to C programming. If there's C programming. Now assembly became very clunky because there were only I mean, four operations possible in assembly. You can add bits, you can subtract bits, you can multiply. No, you can't. Not exactly multiply bits. You could move bits, and the last one you could have no value in that particular bit. So these were the only four operations. So, like, the fourth operation was nothing but space, giving space between bits and bits of memory, such that the computer understands it perfectly. Am I audible?
Yeah, yeah. I guess you got disconnected for a brief moment.
Yeah. I'm so
Yeah,
sorry for
it's
that.
okay.
Oh.
Adi,
Yeah.
before starting, you go to device settings and to noise compression and make it high. We could hear your fan sound.
Thank you. Okay. Now coming to C programming as such. Okay, like as I was saying before, assembly language had only four operations possible. That was add, subtract, move bits, and give space between. Uh, okay, just a minute. I'll switch network so that I don't get disconnected again.
Yeah, that's fine. And also, guys, like you can try to make it as informal as possible. You can interrupt, ask doubts in between. That is perfectly fine, I guess. He'll be back in a moment.
Am I audible now?
Yep,
So sorry for that.
that's fine. That's fine.
Now coming to C programming. Like during the introduction to C classes, which Sir took briefly in the last few days of semester one, he told that C was named just as C because the previous language was called B. But the truth is, there was another language called BCP before. I think it was called BCP or BCL. I don't remember that properly. It was called BCP before B. So the name was natural. Like if at all, another better programming language which interacts with the operating system at such a low level ever comes, it would probably be named P, not to be confused with Python. Python is a very high level language, programming language. Now we have seen. Okay, one more thing. C as such uses a lot of English words to communicate with us and the, I mean, providing an interface with us between us and the computer. So it comes under the high level programming language. Assembly language comes under what's called assembly language, and machine language comes under binary language. So, like if you categorize into these three, these are the places where they classify to be as. Okay. Now, uh, okay. Okay. Now you have written your code in one of these code editors as such, and you're going to hit run. As soon as you hit run, something called as a .obj file is created. What this .obj file has is certain it converts instructions into. I mean, this obj file is created by the compiler itself, which as such convert. You have something called as lexers and parsers. Lexers are nothing but ledgers, or ledgers are registers of functions or keywords, and compares it to what you have written. Now, after comparing it to what you have written, it checks for if it is syntaxally correct. Syntaxally meaning the grammar of the sentence. The grammar of what you have written is correct. If it is correct, it converts it into something called a .obj file. This .obj file as such does not do anything. It simply sits there. Like when you execute it, it converts into full of zeros and ones. Like if you try opening a .obj file in a notepad or a text pad, it will be gibberish. Like you can't make the top and bottom of it, and it is absolutely a waste of time trying to understand what is even written. After that, there are something called linker programs, which converts an .obj file into what is called a exe file. I think you will be familiar with exe files because when you install apps install apps on your laptop, you have to click an exe file to properly install it to and run it. So this exe file is what contains information at the lowest level. That is, it will have full of zeros and ones, which the computer can properly, I mean, perfectly comprehend. Again, you can try to open it, but then you won't understand anything, and it will be an absolute time waste. Moving on. Now you have an exe file setting. For example, there's this test program which I have written, and it says print hello world. Now it has created an exe file. The file cannot be displayed because it either uses binary or unsupported text encoding. Now, if I try to open it anyway, it doesn't open because see, like literally, it's gibberish. But then what happens is yeah, the um, I mean, like the computer OS as such loads this .exe file into the CPU, executes all the statements, and produces a result that is printing hello world. Right? Does that make sense?
Yep. Um, yeah.
Okay, cool. Uh, the next one. Uh, process is nothing but which I've just
Wait, I had a doubt.
told you, that is
Does the You said the
okay. Go on.
exe files has some gibberish in it. Does that gibberish again get converted to zeros and ones for it to be executed?
Yeah, while during execution, it gets converted to zeros and ones.
Okay, okay.
To be honest, like like what you saw over here is just the VS Code's version of zeros and ones. Like the VS Code doesn't understand zeros and ones. I mean, like the zeros and ones as such. So it displays something. It tries to display something because it thinks that something is better than nothing.
Ah, okay. Huh, yeah.
And like that's what the error message itself says, that it's either uses binary or unsupported text encoding.
Okay, fine. I got it.
All these I mean, these all use, I think it uses UTF-8 text encoding, which is a very regular, and it's there it's like a standardized text encoding. But then this .exe file uses binary, like as you can see, and what it understands of it is printed out. I mean, like it's put out,
Yeah.
right? No. Okay.
Yeah.
Now, while explaining about compilers, I had mentioned something called as ledgers and parsers. So these ledgers and parsers are nothing but a list of inbuilt functions, which is written maybe in assembly language, or it's written somehow. Like I tried understanding it, it was not possible. Plus, we don't need to go that deep also because we're not studying computer science. Uh, so these header files contain these ledgers and parsers with the correct syntax as such to compare it with what you have written. So C, being a very basic programming language, I mean basic in the sense, uh, does not do anything for you. You have to do everything for it to work. Basic in that sense, but then C is actually a very advanced programming language. Um, okay, yeah. So you have to include these header files while writing your program. For example, I'll come back here. This hash include is stdio.h. Stdio stands for standard input and output. .h is the file extension for header file. This hash include is what tells the compiler that include this file also. So when you're compiling, the compiler will look for the printf command or the void main command in stdio.h. I don't think so. Look for void main. Look for printf command in stdio.h. Okay. So there's another so, header file called conio.h. Conio is character input and output. I think it's for character thingies. Here in C, you don't have anything called as string. They are all character arrays. It's very important to understand that because in logarithm we were thoroughly thought that there were three data types. Yeah, three data types: integer, character, and sorry, integer, four actually: integer, float, character, and string. String in C is nothing but array of characters. We'll get into that later. Okay. Now moving on.
So for numbers, do we
So
need to include another input-output stream?
that's in stdio.h. Numbers are easy to deal with. I mean, like it's easier for the computer to deal with.
Okay.
Computer doesn't have to work a lot to deal with numbers because, but in characters, we will have to convert it into a number and then store it
Fine.
using either the ASCII encoding or UTF-8 encoding. Somehow it will have to convert it into a number and then store it. Okay. So you don't have to include any libraries for they're called libraries also. The dot header files are also called libraries. You don't have to include any libraries for working with numbers. Okay, so I'll pop a link in your in the chat. Um, as such, many of you might not have a may not have a what's code editor with you. You can go to this particular code editor and online code editor, so it will open within the browser itself, and you can select language on the top right corner as C. Okay. I hope
What's
you
the
are.
difference between C and C Turbo C?
Turbo C is an older version of C. Turbo C uses Turbo C compiler. That's all.
Okay. Yeah.
Nothing much. C++ is written on C. Like there are a lot of features such as object-oriented programming is not there in C, but then in C++ it's there.
Huh.
Yeah. And then I want you to take the entire thing and backspace it. Okay, so we'll write a program together so that we can go through it step by step. Okay. So first use the lesser than symbol and type sorry, not, hash include lesser than symbol stdio dot h. This you're including the header file. As I've told before, header files are required by the compiler to compare against what you have written and what is actually there in the header files. Okay, then click enter twice. It's purely for aesthetics because it looks cleaner. And type void main. There's a bit of explanation to be done over here. There are two types of functions in not exactly two types of functions. There are two types of functions in C with respect to what it outputs. So you can either return a value or it won't return a value. That is like at the end of the function it will either give you a value or it won't give you a value. I don't know any other way to put it. So if your program is not going to give a value to the operating system,
Aditya,
then you put void.
Aditya,
Yeah, go ahead.
can we use int main? Can we use
Yeah,
int
that's what I'm explaining. That's what
main?
I'm explaining. Can, but then that will be in programs where it's going to return a value.
Eh,
Uh,
so what is this BOID point main? Chup.
Void main is nothing but it's you're telling the OS that this program is not going to return any value.
Eh, okay, I got it now. Okay.
Okay. Then open curly braces or flower brackets. Hit enter. This is all automatic. It does that on its own. Okay. Then type printf double quotes because double quote is only accepted in C. Single quotes is not. Like if there are any Python learners here, it's not allowed. And type hello world. Yep, that's basically it. Now, since you have given void main, you don't have to give her any return value. So that's all. No, before that, you'll have to put semicolon. In Python, you have to separate every executable statement with a semicolon. Uh, the semicolon literally notifies the OS that this state, I mean, notifies the OS that the statement is over. Uh, One more advantageous thing is, okay, I'll show that later. Now hit run. If you're able to see hello world over here without any errors, voila, you have written your first C program, and congrats.
Aditya, but why didn't we use uh, character input output here? Because we are using few characters.
We are literally okay. Character input and output. We are not inputting any characters, right? So we don't have to use. Yeah, character is different from the string. I mean, like character is different from. Let's say these are all defined strings. You're not inputting strings from the keyboard.
Okay.
Actually, I should have explained that before. Variables and constants. Okay. One of my.
That's
See, so hello world is a constant. Okay. You're not storing hello world anywhere, right?
yeah.
So, yeah, exactly. So as such, you don't need character input output for printing anything. So printing printf literally um, um, printf. I think it stands for print in the default output device, which is your monitor.
Okay, okay, I got it. So for scanf, we need input include character input output.
If you are inputting characters, you need. I'll come to that.
Okay, fine. Yeah.
Okay. Um,
So by the way, I got the output.
you got the output, right?
Yes.
That's cool then. So there are names to these specific um, what to say specific statements in C programming as such. Okay, um, the hash include stdio.h are called preprocessor directives. You're directing it before the process starts itself. So this is literally the what is going to be executed, right? Before that itself, like since you're giving directives to the compiler that include this, include that, they're called the pre-processing directives, as the name should suggest. Then the main function heading. In this case, I have used int main and I've returned 0. If I don't return 0 also, it's not a problem because by default it will return a 0. But then safer to give return 0 if when you have given int main. Maybe our teachers may cut marks. Then comes declaration and executable statements. Here there are no declarations. We'll come to that again. And executable statement is just printf, printf hello world. And be careful. We have to put the semicolon after every at the end of every executable statement.
Hey
Okay.
Aditya,
Ah,
I'm not
okay.
getting output. I've seen shared one screenshot in chat. Can you look?
Okay. Wait.
Yeah, it's telling some error.
Okay. What does the error say?
There is written something like include studio.h
It's not
complicated.
studio. It's stdio.
Uh, studio. Okay.
stdio.h.
Okay, now it's coming. Simple
Now it's
mistake
coming, right?
then. If there is a
Exactly.
simple, yeah, then it will not run. Okay, thanks, bro.
So that's because computers are dumb. They don't understand things easily. So you'll have to tell each and everything correctly. Only then will it understand.
If you made only some error, then yeah, it will not run. Yes, I mean if you do some error in typing or doing something, I mean in like making
Yes,
some
it won't.
programs, it won't work. Okay.
It won't work.
Hmm. Okay, thanks. Now it is running.
Yeah, no. Did you get hello world?
Yeah, I'm getting. Yeah, I got.
One more thing, don't panic if you get errors, because in like the more you program, the more errors you'll get, more than actual output. Okay, so
Okay,
yeah,
okay.
so don't panic. It's okay. Like it's okay to get errors. There's nothing wrong in the computer telling that this is wrong. Okay, moving on. So, was I semicolon? I was talking about, right? Okay, yeah. So with that, any doubts in this till now? Like, did you understand what are header files, or how does program actually run, and why does it run that way as such? Any doubts till there? Mm, I must taking the silence for no, and
No, there is no doubt
No, no,
actually.
he got it.
yeah, cool. Okay, so to handle different kinds of data, there are data types. Okay, before that, I'll explain something else. Then we'll come back to this. See. This I explained in the beginning itself, how data is stored as voltages across magnetic bits. It may not be necessary, I mean, fields across magnetic bits. It may not be necessary in these directions, but then it is of almost of this form. Okay. Generally, one bit represents either 1 0 or 1. It's either 0 or 1. So either the bit is has a voltage that way, or the bit has no voltage at all. It varies from manufacturer to manufacturer. That is something beyond our control. But then you need to understand that either there is if there is something in it, then it's 1. If there is nothing in it, then it's 0. The same analogy. If it's off, then it's false. If it's on, then it's true. Okay, remember that also. 0 is false, 1 is true. Rather, non-zero is true. Okay. Now coming to byte. Uh, Bytes. If you open a text file and type something in it, that will be stored in that will be some 10 or 11 bytes. 8 bits make 1 byte, which is 8 of these zeros and ones make 1 byte. Then 1024 bytes make 1 kilobyte, and so on. So, like as such, 2 per 40 bytes makes 1 terabyte. Like your computers as such will have 1 terabyte of internal storage. So just appreciate how huge it is actually. So many zeros and ones helping you to display teams, and it's helping you to display this what I mean the notebook as such. Okay. Uh, Now coming to data types. Oh, we'll omit the first three for now, because character will have its own separate set of rules and all. We'll go on with int. Okay, 2 bytes is nothing but 16 bits. So in 16 bits, you can apparently store 32,000. Sorry, minus 32,768 to 32,767. Uh, the reason why 32,768 can't be stored is minus 32,768 can be stored. This minus sign takes up some space, takes up literally a bit, right? So that's the reason why there is one less over here. Um, 4 bits is 32 bytes. Sorry, bytes is 32 bits. Um, yeah, so this much, this particular range can be stored. Unsigned int means there is no minus, which means there is from 0 to 32,767 into 2 is what can be stored. Just add these two, um, and you'll get the proper list. Uh, I think we'll be required to remember these numbers, but then just take a screenshot and as such and keep it. Will be helpful. And the same goes for this int also. Short int depends on okay. till here is what is actually required. These are all are for optimization purposes. Like let's say you're not going to use a number bigger than 10,000. What is the point of what to say? Um, Assigning a int? You can assign a short int, right? This varies depending on upon your use case. So it'll by default reserve 4 bytes of space and run the program. But then if you use short int, it'll by default reserve 2 bytes of space. Then those 2 bytes are what to say, saved. You can call it saved. Um, that actually optimizes program when you're using storage spaces of up to 3 MB, 4 MB, like small devices where you're interacting very closely with the hardware itself. Unsigned shot, again, see, the minus symbol is not there, so the full negative part will go off, so it's 0 to 65,000. Long end, I have never come across. Maybe for banking purposes, they'll use these long end, which has 8 bits. Oh, okay, that's very huge. Um, Unsigned long end is literally the double of that. Float, double float, long float. They are to represent decimal numbers. Now this is e power minus 38 and e power e is nothing but representing 10 power minus 38 and 10 power plus 38. Double float, double of it. Long double is it's 1/3 more. That makes sense. Yeah, so it's 1/3 more. These are some of the data types you can use and see. There are more actually. You can use arrays. You can use in 2D arrays, 3D arrays. But then they are not considered to be data types because they are all called something called data structures. Um, that's pretty much it. Okay, so I would like to show something else also. Now let's say, okay, um, one of the first steps to like we are like slightly advancing. Okay, you'll have to declare variables. Like even in Flogorithm, you used to declare the variables before using it, right? So here the syntax, like the way the compiler can understand is to do it int and a, where int is the syntax for integer and a is a variable, and I have to put semicolon to say that that is the end of that executable statement. Now I'll hit enter and I'll say a is equal to 10. 10. What this is going to do is a is an address to a memory location. Okay, so like in the disk which is running in your computer right now, then memory allocator will allocate int. So this is the regular int, which means it will allocate up to 4 bytes at the address which says a. So it'll allocate 4 bytes and call it a. Now I'm saying put 10 inside a. So like the allocated 4 bytes will be given the value. I mean, not exactly given the value. The value 10 will be stored in those allocated bytes. Now in order to print this, I'm supposed to use something called a format string. Okay. So what this format string does is it behaves as a placeholder for while printing it. Uh, that is because Python, sorry, you'll have to tell everything to C. So like if you're telling I'm printing the value 10, then you have to tell C that I'm print the value 10 from this variable over here. So now let's assume there is some text over the number students.
But does it have to be percentage D itself? Can it be?
Yes, percentage T for integers. Percentage F for float type integers, which is integers with decimal points. Percentage C for what is it, characters. So D stands for decimal, like without the dot. Okay. Now if I run it, the value A will be printed at percentage D. Okay. So I'll run it. Now I got an error because I forgot to put the semicolon in the second statement. Okay. Okay, now we'll analyze the error also. It's a good opportunity.
It is the double inverted commas, I guess.
No, that's what I forgot to put the semicolon. an expected semicolon before the printf. Just read the error. It normally tells you what to do. Okay. Now click run. The number of students is 10. Here 10 holds the value of 10. You could also give a character 10. That 10 won't have the value of 10. You can't add one more to it, right? So that is something um, different about C as such. It will help you create this placeholders. Now let's say number of students is 10. 3 were absent. Even if I do this, A is gonna be printed where I put percentage D only. Okay. 3 were absent. I mean, it's going to say and it's going to say 3 were absent. Now let's do one more thing. Let's give 2 more spaces. It's going to print exactly where percentage D was. So percentage D behaves as what is called a format string. Like I've explained before, percentage F, percentage D, and percentage C are the main three format strings. Okay. Now, any doubts in this until here?
No.
Okay. Anyone else? Like I would like to hear more no's.
No, it's easy.
I'll take the last. Okay, I was explaining this one till now.
I guess someone wanted to speak. I'm not sure.
Ashish, he told
Oh.
na.
Yeah.
We are running out of time. If you have any more doubts, tell it. You can go on right now, or should I start with the operators?
You can start, I guess. You can continue.
Okay, cool. Let's put it this here. Like I don't have slides for that. I have to freehand it. Okay. So there are what? 1, 2, 3, 4, 5, 5 different types of operators. Okay, logical, relational, mathematical, assignment, and unary operators. We'll focus on these 2 for today. Okay, we'll come back to these later because these are more understandable than these 2. These are called binary operators. Us, it takes 2 values for performance of these. I mean, using these symbols. Okay, and these are called unary operators because it requires only one variable as such to what to say to perform operations. Let me give you an example. Okay, we'll take this off here. This. I'll say A has the value 1. Okay, A has the value 1. Now, if I'm going to say printf percentage D, and I'm going to type A plus plus. See, I forgot a semicolon over there. Common mistake people make. Okay, A plus plus. What it does is it does nothing but A equal to A plus 1. So it's a shorthand form of writing this over here. Okay. I will run this. So the result should be 2. Okay, fine. I'll tell you why it actually happened this way. I am performing A plus plus after printing it because look at the order. Like it says percentage D, then it says A, then I'm performing the operator. Now I'll revoke this and type plus plus A. Now it's going to say 2. That's because I performed the operation, then I printed it. This is called pre-decrement and A plus plus is called post-decrement. Okay. like, does that make sense? Like, did you understand what just happened over here?
I got it.
Got it, got it.
So yeah. Uh, Again, the same thing applies to minus also. I can say a minus. We'll do one more thing. We'll say a plus plus, and we'll say printf uh, percentage d, and we'll print a. So what's going to happen here is, effectively, it's going to print one first. It's going to print one, and then it's going to add one to a, which is two, and then here the answer should be two. But then both of these things will print in the same line. Let me show you. It's going to print in the same line. That's because I never told C to move to the next line. For that, there's there's a character called backslash n. Now, when I say backslash n, it literally stands for a new line. Now, if I execute the program, it's going to print it in the next line. There's something called backslash t. And now, what backslash t does is it leaves a tab space from the previous character to the next character. Tab space is nothing but 4 spaces. So there are 4 spaces between 1 and 2. They're also uh, types of format strings. Now, okay, so unary operators are clear. Binary operators. I mean, you are familiar with this add, subtract. So now, like if I have to perform a binary addition over here, so it will be a equal to a plus 1. So now this will be a binary thing, because I have one variable, I have another variable, then I'm adding it using a binary operator, and then I'm putting it into I'm putting into the variable called a. Uh, uh, Now with that, uh, closing the session. Any more doubts?
Do we use BODMAS rule in the C programming?
Yes,
BODMAS rule.
it's called hierarchy of operators. I thought I'll take it in the next session.
Yeah. Okay. Okay.
There's
Sure.
yeah. Same. It literally uses board mass only, brackets of then division, multiplication, addition, and subtraction from left to right. But then
Okay.
here even expressions will come. So like all these and or not operators will come, and they also will play a role in board mass. So like they'll also come in between and create ruckus as such. So that will also have to be kept in mind. So I'll start with operators next class. Then we'll slowly move on to control structures like if, for, else, I mean for, while, do, while, and on. Any more doubts?
The session was on point. I really liked it. It was very informative too.
Thank you.